So we're going to start today off with controlling Hashrate heaters. This, to me, personally, is like the biggest thorn in my side, which is like, you know, we have these, the production of heat is easy. The ASIC chips produce heat. That's like not a problem. We don't struggle making heat. We struggle controlling it. And there's a Pirelli quote that's like, power without control is nothing, you know? So like if you have a car with a massive engine and you can't stop or steer, it doesn't really do you any good. And I think that's where we're at here, basically, for me anyway. And there are systems to work around this, and that's what we're going to get into today. So I just want to go through, with all three of you can kind of chime in as you want, but let's go through like a basic history of control. Where did this stuff start? Do you guys know? As far as I remember, and I haven't been around forever, but of course you have on-off switches. That's probably the very beginning, I guess. Okay, you unplug the miner. But when was the first, like, what do you think was the first control, like, layer or, you know, tool that we were given, basically, or created, for that matter, to start controlling these miners?
Yeah, sure. For me, it was really like the first custom firmwares.
Yeah.
That had like, you set the max temperature, and whenever the temperature of the hash ports was reached, the miner would like basically throttle down. So that's the very first time that I got in contact with the capability of like, okay, I could kind of heat the room. The problem is, it's very hard to know if you can tell the miner on which chip temperature it should throttle down. How do you know which chip temperature relates to 70 degrees in the room? Like that's extreme. That's almost impossible. So my first cases was like, okay, it's either extremely hot or not. Like that's basically that works in your own garage where you hang out by yourself and you have to wear headphones anyway all day long because it's way too loud. But yeah, as soon as you talk about like comfort heat, like this is not a comfort setting, hot or not. So yeah, that's when then I looked into other ideas. But I think for me at least, that was the first time that I realized, hey, I could actually use these miners to start to produce some kind of heating system. And
this was like, you're referring probably to dynamic power scaling on brains? Is
yes,
that
correct, yeah.
Okay, so I think that was, then I think maybe I'm right here, and then that was the first major step in like having some rudimentary control over miners.
However, though, like I think we saw like Bitmain actually played with some space heating solutions where they like made really long miners with like fans. Oh. And I think of pictures that you look at them, they had temperature sensors externally. So they had ambient temperature sensors. So I think there definitely was a time that the big ASIC producers thought about this. But yeah, as we know, they completely stopped and just focused on industrial mining then.
Mm-hmm. Well, like even now, like Watts miners actually have a parameter in their API that's environment temperature. I don't know where they're sourcing it. I don't know what they're doing with that information, but they do actually have a quote-unquote environment temperature sensor.
Huh. Right, yeah, I didn't heard of that. Bob, you use a control system that is unlike what most of us are familiar with. And I would say maybe if we think about the history of controlling miners, your systems predate miners, I think, right? Even now? Like you're basically, why don't you explain like roughly how you're controlling your system?
So, and I think, you know, I'm using a miners like everyone else is. I'm using, you know, brains to kind of, you know, amp up and down the actual power coming out of the miner. But the way I built it is to treat the miner as just a dumb supply of heating. And then I use everything externally to that to control how much heat goes to different parts of my house and to modulate it that way. So, you know, you've got kind of two levels of control to think about. You've got the miner itself that you can turn on and turn off, ramp up, ramp down. You got a lot of really cool tools that I use too. They're you know, the dynamic performance scaling is, you know, the keys to the kingdom here. But outside of that, we literally have 100 years of controlling thermal systems in houses. And the more you can lean on that, that's all done. It's out there, it's cheap, it works. HVAC folks understand this stuff. And so I leaned really hard into that to use that to actually say, okay, I've got this supply of heat that needs to be moved around the house. I used all of that to actually, you know, get it to where it needs to be and then to modulate it.
Mm-hmm. So you're using like contactors and relays, all these like old school, what, you know, I think it was like old school compared to, you know, the software end of things.
Yeah, I mean, you look at, you know, old relay technology, it literally is 100 years old.
Yeah, the good thing is a relay doesn't have a software bug.
Yeah, exactly. Well, yeah, we'll get into that. We'll get into reliability issues here in a minute. So what do we have now? Basically, let's set up like the current status, or actually let's walk through Home Assistant, which was the next, and I think probably the next great software innovation for like pleb mining as far as controlling miners. And both of you have major parts in this. So.
Yeah. So for me, as soon as I played around with it and I saw the dynamic power scaling, I was like, okay, there should be another way to do this. And looking at that point, I used an S9 and looking at how the UI talked to the miner and like looking at the APIs were not really documented, but you could see like there is hints of things. Like for example, Brains has a setting to turn the miner on and off through the API. You can't see this through the UI, but there is an API for it.
They did have documentation for this on the S9. Pause, resume.
Yeah.
It was hard to find the documentation, but it did exist. But like, if you wanted to get into the stuff that really didn't exist, back on Brains on the S9, like setting a power limit was basically impossible unless you did it through the UI. The way that I ended up having to do it essentially was there's a configuration file on the file system of the miner. So you would SSH in, and then you would read that configuration file. You would parse that file, and then you could modify it and send the whole file back to the miner. And that was pretty much the only way to change power limits on like old S9s.
Yeah. As you can see, this is like for a construction worker like myself. This is not.
Yeah,
it's
no
problem.
But yeah, so I played with this and I saw like, okay, what control systems could I actually use to tell the S9? Because while technically there's a Linux running on the S9, so there technically you could connect something to the USB and add a USB temperature sensor. It would technically be possible, but the Linux is so shut down that you can't do anything on it. And so we had to use an external system. And I played before with Home Assistant already for other stuff around. And what I really like about Home Assistant, there is more than 15,000 integrations into all kind of other thermostats and solar panels and floor heating and presence sensors and buttons and knobs and everything. So for me, it was obvious to use something like that. And the great thing about Home Assistant also, it's completely sovereign. So like nobody can access your data. Like it's all running on your home computer.
And for context, anybody who doesn't know what Home Assistant is, you can think about it like a self-deployed Google Home, essentially. So
Correct.
You have access to a whole bunch of devices in your home, and you can kind of control them from one central system. And then being open source, random people can come in and write integrations for it. So if you have a device that maybe doesn't have native support for Home Assistant, you can actually write in support for that device.
Correct. And so then I went to Bitcoin Miami, I think 2022, and I talked to a lot of people, including Brad. It's like, hey, like how do you, I talked to the big miners because I assumed like they talk about curtailing and all that stuff. So me coming from a naive like open source software world is like, oh, there has to be an open source software that can do this, that we can use. And lo and behold, unfortunately not. Like every of the big miners, they completely built their own software. There's 4man, which is not open source. So I was like, I guess you have to build it yourself, which what I did. Like I just wanted to control my garage. So I went home, built the first extremely simple integration into S9s and only S9s. And then everybody came like, hey, can I use this with that and this other miner? I'm like, I don't have these miners. Like, how can I? Because again, there's not a real documentation. So the only way for me to build this was to actually have physical access to the miner. And then I talked to this guy and he said, hey, I have a tool that is called PyASIC. Because in upstream, you have to control a lot of different miners. And he basically did all the hard work to figure out all the different APIs. And for anybody that wants to have like some fun, like look in the code of PyASIC and see how crazy it is, because these miners, they don't care about us at all. Like they literally change the APIs in patch versions of the firmwares. It changes.
When I first started, actually, it's so funny. Like I started with S9s, and eventually we moved on to Watts miners. And Watts miner APIs, when I started working with them, were so bad. So they're supposed to be in JSON format, which is like there's a specific way that you're supposed to handle things. There's key value pairs. You can put some different stuff in there. They were doing so many things just completely wrong. Like things that if you were using a proper JSON parser should not even be possible. It was so messed up. And so like there was a lot of bullying that went into that. But for context, like if you want to get an idea of just how stupid some of these APIs are, Bitmain stock is probably the most egregious one. They support like a basic CG miner API. So CG miner is like kind of one of the early ASIC mining processes written by CK. and pretty much everything nowadays is built off some form of CG miner. So they supported the API from CG miner, which was relatively well documented. But then they went, oh, well, now you can pass this parameter new underscore API to get this completely different API, but only on some commands. And also now we have web endpoints that you can hit that are going to give you sometimes the same information as the new API stuff. But then there's also different ones that don't give you that information. Oh, and now we're going to tack on with the S19s another API that's like a debug API that people at like repair facilities might want to use. So there's like 7 different places to source all this information. It's bad.
Question, put you on the spot. Do you think this is just because they're going as fast as they can and they're just hacking it, or do you think there's some deliberate, hey, if we make this too easy, folks are going to get into, under the covers here?
There's not really much to get under the covers of. Like if you know where to look, you can get into S19s. Like you can. They have SSH access open by default. You just have to know what the username and password is. And for anybody who wants to know that, fun fact, it's miner is the username and miner is the password. So you'll get some basic access to the back end of the S19 there, and you can sort of look at some of the sources of like their web files and stuff like that. But I don't know if it's because they're rushing or because they just don't have any standard to conform to. Like I think that's going to be one of the important things going forward is these manufacturers need to have an actual standard to conform to. This is what all of the big miners and all the pleb miners and everybody expects out of you. Go do this thing. I think that's going to get really important really soon.
I think the problem is they don't have any competition. Like, why would they need to do this?
Yeah.
So the only thing for us to force them to either join or die is to build our own stuff, make it better, make it more useful, deploy it more often, and then they can decide themselves, okay, are we going to join the train or not? Like, it's open source. It's going to win eventually. Like, look at Microsoft and Linux. Like, right now, today, Microsoft is one of the biggest contributors to Linux. Like, this was not the case 20 years ago. And they realized unless we join them, we're going to die. And so that's the same that needs to happen now. So that's why I'm extremely excited about all the
We're
open
so
source.
early.
Yeah. But obviously right now we want to build these things. And coming back to the story, like PyASIC, so for anybody that wants to talk to miners, like I really, really encourage you look at that thing, because all you give PyASIC is an IP address of your miner, and then PyASIC does all the stuff for you. It knows like all the different 7 APIs. You just talk to one API of PyASIC and you tell like, please turn this miner off. And PyASIC knows which Brains version, which Watts miner version, which whatever version does it even have an API for this and that. So it does you all the heavy lifting. So in my case, my Home Assistant went from supporting 1 miner to like 50 miners with one
50?
change. Or I don't know how many. How many?
Oh
support?
man, there's more than 50 submodels of the M30S.
Whatever. See, which I don't know. I don't even know this stuff. Like, that's the great thing about open source, the fact that I can use his brain and his knowledge, and I don't need to worry about this. So yeah, if anybody wants to use, like, think even, and now we have support for bit access and everything. So if you want to think about anything, talk to a miner, please, I encourage you, use PyASIC, because it's going to make your life much easier. And pay this guy beer.
I want to get into PyASIC actually, and Home Assistant. I want to stay on this for a second. I want to get into reliability. So I've been using Home Assistant since you deployed. I mean, like literally, I think I was probably one of the first guys to watch your video on like how to set up Home Assistant. And I was like, oh my God, this is it. We can do it. It's like we're heating the world with Bitcoin now. And then the last 3 years has been, a mixed review of Home Assistant from my end. But how reliable is PyASIC? And Bob, I want to ask you, are you using Home Assistant, are you using PyASIC, or are you just using Brains DPS?
I use Brains on the machine. Just so the way my system is made is, I dump all the heat to the house first and then to a dry cooler outside.
Oh, so you are dumping heat outside. Okay.
Yeah, and it's basically priority. My house gets priority, my hot water gets priority, my garage gets priority, and then outside. So my miners go as hard as they can based on the cooling they see. So basically, if the temperature of my tank starts getting up, the miners throttle back. So they just sit there and just try to kind of ride that wave and produce as much heat as they can. And then the rest of the system, like I said, using all the traditional HVAC stuff, decides where that heat goes. So if my house really needs it, my miners ramp up to as much as they can. In the middle of the summer when I don't need any of it, then the miners go all the way back down, and I'm just using the dry cooler.
So you're doing like a traditional HVAC system, whereas we're looking at like how do we do the most giga ridiculous, silly, weird stuff. Yeah. Like yours is, hey, how do I make this into a heater that stays in my boiler room and is hooked into my HVAC system? And I guess from mine and Schnitzel's kind of perspective, we're thinking, okay, how do I have a an S9 in every room of my house that is a heater that I can control to heat those different rooms.
Yep. And I think the distinction here too is that, Bob, what you're doing, you have this easy outlet, this relief valve, which is that dry cooler outside. I don't have that luxury, or I'm like unwilling to do it because I'm kind of somewhere between you and these guys, where I'm trying to do some crazy giga stuff that I'm getting in way too over my head. But when you have that release valve, it makes it easy. It's when you don't have that, that's when you get tricky, because dynamic power scaling works like pretty well, but it's maybe not as granular as you would want in the up, and like being able to like really get precise.
Yeah, at that point you would need to, again, we have the ability. I mean, thermostats turn your furnace on and off, right? Is you need some feedback into the system. At that point, I think that's where you do engage with Home Assistant or some layer above that, because you really don't want to be, flipping a relay and hard chopping your miner on and off. You want something that does that gracefully.
Yeah.
So I think even in that world, you're going to have some software layer above that, but that still can be done at a central heat source basis, where your miner does still ride the heat, but then turns off in the summer when you don't need it. So I think all of these are tools in the toolbox. We have all these different things, recent, old stuff. That you can use to build a system. And I think this is what's really cool about this, is we're all looking at this a different way, all using these different tools. And I think over time, we'll start seeing what's the most effective, what's the most reliable, what's the easiest. All this is going to come together, and we'll start coming to a more standardized way of how these things get deployed.
Yeah. So let's go back to PyASIC and Home Assistant. How reliable is PyASIC? Like, what is the uptime? Does it fail? Does it make mistakes? Is it pretty hardened?
Absolutely. It absolutely does.
Okay.
And
because
it sort of depends on the miner. Like, Watts miner's relatively stable as long as you're on a recent version and MicroBT hasn't done something stupid. Like, MicroBT has an actual continuous integration system. They essentially, every time they make any changes to the firmware, it gets built. They just don't release it to the public every single time. So, like, for example, you might get a miner with some random firmware version on it because you bought it from the manufacturer, and they might have introduced some bug, or they might have changed the name of something in the API that just breaks everything, and they haven't really told anybody about that. So stuff like that tends to happen a lot. Or I guess a really good example is recently I had a guy complaining, I've got my S19 running, but like every once in a while I'll reboot it, and instead of showing up as an S19, it'll show up as unknown. And he's like, okay, but it's giving me this error, unknown miner type, BHB XXXX. I'm like, well, I can't use that to actually identify that that's an S19. That could be literally any S19 model. Like the S21 sometimes will identify as BHB 2426 or something like that. But you basically just get this random garbage out of the miners sometimes that makes it almost impossible to use them the way that you expect to use them.
Yeah, but this is I want to get into it, so I'll lay down. Brett knows this already because I just get on GitHub and whine about why my Home Assistant has broken. It generally, my system works if Home Assistant was hardened and it worked reliably and updates didn't break things, and like all these problems you're talking about. I actually think we'd have a solution to the control problem, but currently it just isn't reliable enough. And I want to hear your input on this too, Schnitzel. Is it reliable for you? Do you have these bug problems, or do you? Or is anyone, or you guys, would you even advise just like halting at a prior stage and just freezing there? Is that something that could be done?
There's a certain point where, yes, there's some software complexity that goes into like trying to deal with building software for another platform, which is essentially what this is. A really good example of this is a while ago, PyASIC has to use a beta version of a piece of software. It's been in beta for like 3 years now. For talking to Brains OS miners, like the newer ones via their gRPC API. And there's basically nothing I can do about it because it's the only thing that works and is reasonably good. Like the Google Proto-C compiler is just garbage. But I essentially have to use this thing. But Home Assistant just will not allow me to install beta packages at all. So I was like, okay, guys, like Home Assistant, can we fix this? Can I have some way to flag this in or just allow this for only this specific package or something like that? And they're just like, no, get screwed. So I literally went in, I copy-pasted the way that they're installing packages, and I am just patching it. Like I'm putting in the most hacky possible workaround to deal with this, but I have no other option. There's like nothing else I can do. So there's a lot of cases where it's like, okay, some disagreement between me and the Home Assistant developers is really, really annoying. Stuff like that tends to be kind of the biggest issue, or like they'll change a package version that I'm also using, and then I have to make sure that I conform to that package version and I can actually use it. Yeah. It's really complicated.
As you can hear from Brett's description there, it is very complicated. And I really appreciate you guys working on it because I would not be able to do this stuff without it. But I'm wondering, is all of this complexity even necessary? Bob, maybe you want to weigh in on this. But like, would it just be easier to like simplify things? And I want to ask this at the ASIC Frontier panel later today. As far as like duty cycles on miners from hard shut off and hard turn on, like maybe we don't need to be so granular with this control. Maybe there's a way to find some middle ground between using physical contact or control and hard on off, and maybe simplifying the software end of it somewhere. I mean,
I think that's going to be the key here, right? Is you've got stuff like Brains OS, dynamic performance scaling, where you can ramp up and down the miner. That works great. But at some level, at some point, you're going to have to turn these things on and off. Even in my system, I got a big old switch that hammers a relay, right? That's not ideal. I mean, if you look at how furnaces, how air conditioners work, all these other things, they either are built to handle that, which miners are not, or you've got some level of control, like I said, that shuts these down gracefully. So I think maybe that's a new thing to build, is an intermediate layer that's maybe not the full-on Home Assistant software package, but is something that I don't know if it resides on the miner or I have to have reside on like a Raspberry Pi or something in between, but is that simple on-off, really a simple on-off switch or control that would kind of bridge that gap. And I don't know if that again, it's a tool. Would that be used? I don't know.
I think that's where we're going to. Like, so to answer your question before, like. Yes, it would be, so technically like Home Assistant actually has whole alpha beta versions, and we could have like stable versions of HasMiner and stuff like that. The problem is right now we don't have a test system. Like it's really hard for us to actually say, okay, if we release a new version of HasMiner, like does this even work? Like, so that's the first thing, like having maybe a space.
I've been getting better at this. So my computer at work, sometimes I'll spin up like a dev container or something like that and actually test it. And we'll have a couple miners running, and I'll make sure everything works reasonably well. Like it's been getting better.
But yeah, so like having like a space where like, let's say we put 50 different miners in it, even though there are 500, let's say you start with 50, and we could actually run a test. Like then,
well, the WattsMiner API is all going to be the same. Like as long as you're on the same version, they use the same piece of firmware for everything and 30 onward.
But we could have different like one previous version and one previous version before. I don't know. It's like we don't really have a test system. There is no virtual miners that we can start in a cloud and say like, okay, does this actually work? The only way for us to really test is to physically buy a miner. So like that would be one cool thing. And then we could say, okay, if we release a new version of HasMiner, we test this against this, and then we can say, hey, we tested it. So that would make the whole craziness that like we release 3 versions in one day would go away. But
I actually did try that for a little while, the like whole miner emulation thing. I can emulate an S19 really, really closely, other than obviously the mining process, but I can fake the APIs, I can fake the web interface. It's really funny, actually. I built this thing. I'm like, we should really test against this. And I'm like, maybe I should just say that I have like 150 exahash and hook this thing into Foreman and see what Foreman thinks of that.
So if anybody in this room has any knowledge about hardware emulating in the cloud and stuff like that, or like software, like talk to us. Like this could really help. But coming back to what Rob said, yes, right now, honestly, what we're doing, like, it's so stupid. Like we have hash boards, they get controlled by a control board. There's literally Linux running on there, but we cannot change anything on that Linux. So what we're doing is we're creating a second Linux box that runs Home Assistant. But the problem is that Home Assistant can't actually talk directly to like switches and relays. So we run as a microcontroller, which is mostly an ESP32, that talks to Wi-Fi to the Home Assistant, so that then the Home Assistant can talk through the API to the miner to do stupid things like, oh, it's 70 degrees in the room, maybe turn off your mining. Like that's like literally that's you need. Like if I show this to people that are not from this space, they're like, you're completely stupid. Like this is so, but what's going to unlock this is going to be, again, open source. So I don't know who of you has seen about, like, the BitX project turns now into a much, actually, more hash board. So the 256 Foundation that recently found a block at a terahash, they now have around $350,000 to invest. And they're going to invest into open source control boards so that in the future, we can actually attach a temperature sensor to the control board, and then you can tell the miner, hey, if this temperature sensor tells you it's more than 70 degrees, turn your mining off. And we don't need Home Assistant anymore.
Right.
We don't need ESP32s anymore. It just all happens on one miner itself. And I think that's what's going to make it much simpler.
And that's still going to take talented software developers, but in a different space than miner API control. It's going to take people who understand the mining process and who can go in and build the custom Linux image that you need for this and modify your actual mining, think Boss Miner or Lux Miner or whatever, in a way that will actually read that temperature sensor and then make it useful to the user. So the user could maybe say, okay, within this range, I want the miner mining at this power limit. And within this range that's slightly lower, I want the miner within this power limit. But then if it goes above this, then actually shut the whole miner down. And we need people to do that at that point.
So from like a dream scenario standpoint, where will control happen in the future, do you guys think, on these miners? Like, is this all going to happen on our control boards? Like, is it all just going to be tied right to each miner? Or are we looking at running servers? It sounds like, Schnitzel, you're talking about, everything, or much more of it at least, being done on board the miner itself.
I think it should be everywhere at once. Like you should
I think
have,
it has to be.
Yeah, you should have different possibilities.
Okay.
Like if you have one miner and you just want to control, like you have a space heater and there's a little temperature sensor on top, that's it. Like that should be the simplest way. And if you want to go crazy and let's say you have 3 space heaters in the same room, they should maybe share the temperature sensor. Like there should be a way that they can talk to each other and say, let's all start. Or maybe if we get closer to the temperature, maybe just one of them starts to turn off because we don't want to overshoot the temperature. Mm-hmm. But then also if you have like whole distribution systems that now runs multiple apartment complexes and each of the apartment complex has their own temperature sensor, that should also be possible. Like that's what I'm talking about. Like I want to build a system that creates the base for if you want to go crazy with Home Assistant, you can, but you don't have to. And right now, the problem is we can either do all mechanical or Home Assistant. Like there's nothing in between.
Go ahead, Bob.
So,
Well, you go first. I got.
I think essentially the idea is the larger of a scale you get to, right? If you're doing one miner, it's a lot easier to go mess with that miner and fiddle with individual settings and just optimize it exactly the way you want it. The larger you scale up, the more miners you have, the closer you get to a large farm setup, the more you want one centralized controller where you can go view and modify all this information in one place, and that's going to have to happen through the API. So there's something to be said a little bit for we're going to need both of these, but different people are going to need different levels of this.
And I want to answer this in a little different way.
Yeah.
Look how all of our homes are heated right now. You have a furnace. You control the furnace. You don't control the gas. You don't control the burner. You don't control the fan. You control the furnace. To me, if you ask me what is my dream, is that it's a Bitcoin furnace. You have a thermostat in your wall. I want it 80 degrees. And there's no talking to miners or control boards. It's all integrated in this appliance. And I think it's taking this a little beyond what the discussion here is, but I think a lot of the stuff we're working on now is the bridge to get there. And that I think we have to make these more proof of concept systems that, you can heat your house with mining. Look how easy this is. Once we get that to where it's something where there's enough of us that can show that this works, I hope that your carriers, your trains, your big furnace manufacturers go, oh, really? Well, I can build this. And then it's a furnace that just happens to be powered by Bitcoin.
Well, so for example, the way a furnace and a thermostat generally talk is like a couple wires. So you'll have maybe like a 0 to 10 volt signal, so an analog signal from your thermostat to your furnace. Your furnace has a control board inside of it that's going to take those wires in, and it's going to convert that to some sort of signal, and then it knows, okay, I need to modify the gas to do this. I need to turn the fan up more. I need to turn the fan down. I need to shut off. I need to do whatever, right? That's, I think, the direction that Schnitzel's sort of talking about is with open source control boards, you have the ability to have those inputs. If you want to build a furnace and you want to do that off an open source control board, well, maybe you have some header that hooks into your control board that goes, okay, I have 2 wires, 0 to 10 volt control. That's coming off my thermostat. And now I need to modify the firmware a little bit so that it understands, okay, this is what this signal is. And here's how I modify the parameters of the miner based off of that signal.
I think we are desperate, dangerously close to solving this. That's what I think. I think we're really close. I think right now my system operates like you're talking, Bob. Like my wife's at my house in Wyoming right now. The heater, my boiler turns on and off. My Bitcoin boiler turns on and off, probably 8-10 times a day, and depending on load, if it's warmer or colder outside. No issues until I go to update, and then the entire thing blows up, and I'm on GitHub with Brett saying, why why is this not working? I shouldn't have updated.
Update your Home Assistant, update your Hash miner, update your miner firmware.
Do not do this. Brett is.
If you're going to update one thing, you have to update everything. Yeah.
Okay. Well.
No, but we feel your pain. Like I feel your pain.
It's a pain. Yeah.
It's the same. Even though I'm one of the maintainers, it's every time like, should I press this button now? Or not?
But I just think I think you guys are doing God's work out there, because it's amazing what's been done already. And I think if we can get some relief from our overlords at the ASIC manufacturers.
We won't.
Okay.
No.
Well,
not from the manufacturers.
We'll have to make our own luck.
We have to build it ourselves.
Even like some firmware has been a bit of a pain. Like, I'm not a big fan of presets. Everybody at Luxor and also at Vanish knows that I absolutely do not like presets. I think they're ridiculous. But I guess I should give a shout out to Wilfred Allen, who is here somewhere. He essentially, what he did is he went and said, okay, what's the closest preset to the power limit that you want to set? Okay, we're going to just use that preset. So now it makes things a lot simpler in Home Assistant to actually just control those types of miners as well to the sort of power limit you want. So it's getting better, and we're adding new features all the time, but sometimes those new features break things, and that's just going to happen sometimes.
So
if I can add one thing, like that's the crazy thing. Like all these problems that we have at our homes, the big miners also have, and they already also solved. So like we need to also get them and explain to them that they need to contribute stuff back into the world as well, because honestly I think they're part of the problem as well.
I'm working on it.
They're like, it's not only the ASIC manufacturers that have proprietary hardware, it's like all these other companies that figure this stuff out and then think, oh, I figured it out, now I keep it for myself.
Yeah.
Like that's the other thing we need to dismantle and change.
The crazy thing though is like they have figured it out for 2-3 types of miners. A lot of these guys don't have it figured out at anywhere close to the scale that, honestly, that PyASIC has. Like, they might have support for Watts miners, but, they have to change the password on their Watts miners with the Watts miner tool before they can do any control. Or they might have it figured out for S19s on Brains OS, but it doesn't work for Lux OS or Stock or Vanish if they decided they wanted to change firmware, right? These guys kind of solve one very hyper-specific problem, and they do a good job of solving that one hyper-specific problem. But the issue right now is that everybody has solved one hyper-specific problem, and they're keeping it all private. Yeah. Now, if every large company, every Marathon, every Riot said, hey, we have this system, this is how we've built this is how we're controlling this specific type of miner, and then they all combined their efforts and said, okay, we're going to make this universal miner translator, like that would literally be the best thing ever. It would be perfect for everybody to use. It would be super well tested, and it would support essentially every type of miner that anybody ever could want to use. Yeah. And that's what I'm trying to do with PyASIC, but it's a little harder because it's like I'm one guy. I have access to like 10 different types of miners at any given time. So there's some hacky workarounds that I have to do to like get more information on different types of miners.
And I mean, that is not unheard of. Like if you go into regular like software development, like specifically like in the Linux, there all the companies work together. Like if there's a security issue, you literally have the biggest competitors on Zoom calls talking through it. How do we fix this stuff together? Because at that level, we're talking about engineers working together and solving problems. And all the people, or the executive or the whatever, like all these people on top, they don't have anything to say anymore. So
because if all their systems break, like it needs to get fixed, and it needs to get fixed right now.
Yeah, and what I'm asking for is like we should start to do this as well on a miner. I'm not saying like share each other's trade secrets and whatever, but just like show, like open source your tools. Just show us what you're doing, and like that's the next thing. Like right now, if you go into any big miners, the only tool that you really can use is Foreman, and it's completely closed source, and they have no incentivization at all to do this. So like my hope is that eventually we can build a tool that works for home mining, that it becomes so good that the big miners realize, hey, we can actually use this. Because I talked to some of the big miners, and they say, yeah, if I want to like integrate with some like curtailing thing, I literally have to ask somebody at Foreman to build it for me.
Yeah.
And if it would be open source, they can just add a plugin, build it themselves, hire Brad, who are like a clever software developer, and build it themselves. And they look at you and you're like, oh yeah, I never thought about that.
So who's funding PyASIC? What is, I mean, what's the deal here? I mean, is the 256 Foundation, are they funding PyASIC, for instance?
No. PyASIC is funded by essentially Upstream Data entirely. Right. PI6's kind of weird because it's something that we're using, and I see absolutely zero downside to open sourcing it. Everybody is doing the exact same thing for miner control. Like, nobody is doing anything special or unique. And so the only thing that happens if I open source PI6 is more people might want to add something to it or add support for their miners. It's not like I'm releasing trade secrets, right? And we use it internally, so the better it gets and the more people contribute to it and use it and enjoy using it, the better it will get, the better it is for us. And that's the business case that I have to make to like the higher ups at upstream, right? It's only going to get better by open sourcing it, right?
So I can tell, like,
the conversation, I guess, you bring up the 256 Foundation. One of the things that I'm working on is I've been talking to some of the software devs at like larger companies like Marathon, like Riot. I said, yeah, I'm working on getting this done. I want to essentially rewrite PyASIC in Rust because I know everybody in the Bitcoin industry loves Rust for some reason. But no, you get language bindings, so you have access to it from a lot of other programming languages. It makes it a lot easier for more people to use it. And then it's also nice because the bigger guys will contribute to it. But I've been talking to them. They all seem to have an interest in it. And the 256 Foundation seems interested in maybe bringing some developers to actually help work on that. So I've got the information already on how we would do this. It's just we need to find people to work on it. And we need to start doing it.
So in relation to this, if like there's a lot of guys here who have physical products that I think work really well. You know, it's immersion tanks. It's maybe easier for many people to build in the physical world than it is in the software world. Where do these guys go if they want to hire someone to develop like a control system for their miner? I mean, should they just or should we just be contributing to something like this PyASIC, you know, consortium of developers or whatever to get PyASIC lifted off and get it reliable and, you know, get more development on PyASIC? Or should they just make their own thing?
I would say no. I think the boutique, hey, you know, we're going to have a bunch of these different systems around. We know where that ends. I mean, we're living that right now, right? And to me, the universal or centralized solution here, open source, is really where it needs to be. And one question I have is, you know, if you look at the software industry out there, you know, all these different open source consortiums that have started, why? It's because they sat in this scenario at some point in the past, and someone said, enough's enough. We're going to make an event and find folks like you at all these different miners and have an event that maybe it's just like 5 of you at the beginning, where someone kicks us off and says, we're going to do this. So it sounds like we're kind of at that point in our industry where someone, who knows, maybe someone in this room, takes the initiative to say, no, we're gonna have, you know, day one of this consortium, we're gonna give it a fancy name, give you all T-shirts, whatever, and have you show up at, you know, maybe it's a Zoom, maybe it's something, but just start it so that the conversation begins. Because it sounds like that seems to be the big limitation, is that we're not even trying to start that conversation.
Yeah. That's literally what I've been doing at. Like, that's what I did at the Nashville Energy and Mining Summit. That's what I'm doing here. I'm networking with people and trying to figure out, okay, who wants to work on this? What do they want out of this project? Like, how do we get this started, right? That is exactly the goal. How do we start this process and get it rolling? And to your point, like, oh, as somebody with a system, do you just contribute to open source? Well, not everybody can do that, obviously. I got to give a big shout out here to Epic Blockchain. I don't know if anybody knows about them. They do some hardware stuff. They do some firmware stuff. But there's one guy, JP, there, who has contributed a whole bunch to PyASIC for their system because he can, and it's good for him because he understands, oh, this is the mistakes that we've made in our API. This is how we can improve it. But I don't necessarily expect every miner manufacturer and every firmware developer to do that, right? The best thing I can ask for is actually document what the hell is going on. Like, where can I source, for example, power information, the MAC address of the miner, the hash rate, the expected hash rate, the chips per board, all this type of stuff. If people can at least provide documentation on where can I get this, I can implement the rest. Like, I understand how PyASIC is architected. I understand what I want to do with it. I just need to know, where do I get the data from your miner?
Okay. I want to start closing out here and ask you guys just if there's anything else you want to comment on. And then I've got one question from the crowd, and we'll wrap it up. Anything you guys have left to say?
You know, we're here today because, you know, folks like you all and other folks in the room, we've decided to try and build something. And I think that needs to continue. And you hear frustrations and problems and upsides and downsides. You know, I want to make sure everyone realizes here, yeah, we're kind of pissing and moaning up here because we're living it like, these things suck, but we're all making these things work.
Yeah.
And the more of us who go out and build it and try it and build in our home and then tell other people what we're building, what we've learned, how things have worked, how things have failed, the more all of this knowledge base grows. So that's one thing is as much as we kind of like, this is not the best, build it, try it, use it. That's how it gets better.
Yeah. Well, we're complaining because we want it to get better. Yeah. I don't sit up here and go, oh, well, this thing sucks and this thing sucks and this thing sucks because I hate working on it. I love working on this stuff. It's what I enjoy doing, but I also want there to be a systemic change in how we're doing this and how the whole industry kind of functions on that side of things, because it makes things easier on me. It makes things easier on people who want to do hash rate heating, who want to do all the control systems, who want to do all this fancy stuff. Yeah. The easier we can make this, the better.
Yeah, I mean, this is like, well, go ahead, Shinsel, sorry.
No, I mean, I 100% agree. Like I said, like 2.5 years ago, nothing of this existed. And like there, I could only moan about that it doesn't exist. Now we can talk about it exists and how can we make it better.
Yeah,
so
now we can complain about the fact that it does exist.
But I think, it's true. But the problem is sometimes I feel a little bit that people are, they're saying, oh, it exists, so it's not, we don't have to work on it. Like, we continuously have to work on this. So I encourage everybody, like, yes, if you're a manufacturer or producer, or if you build APIs, make sure they're properly documented so we can integrate with them. If you have a home system and you want to use it, try it and tell us what works, what doesn't work. And if you have none of this, but you think this should happen, like there are now 501c, like the 256 Foundation is now, like you can donate there tax deductible. So like if you have some money, they're saying like, I can't code, I don't have a miner yet, but maybe I want to buy one in the future. That's your way to help to make this possible.
I guess the TLDR there from like my side of things is information is going to be the most important thing. Information from users who know what they want, information from manufacturers who know what they've done, and just information in general. That's pretty much the most useful thing.
Yeah. Yeah, I would encourage everyone that thinks they can't contribute. I mean, I run Home Assistant, and I don't know anything about coding at all. But I get on GitHub, and I tell Brett when things are wrong. So that's my incredible contribution.
It's massively helpful for the most part.
So. I've got one quick question. Do you guys know if the Loki board introduces problems with PyASIC or Home Assistant? I can't imagine it would.
I don't think so. It's all it is a PSU spoofer. So essentially what the Loki board is doing is telling the firmware, which expects to see some specific control board. So like on the S19s, it wants to communicate with the control board. It's just saying like, hey, I'm a power supply. I'm not an S9 power supply with no control board or nothing in it. I'm actually a real power supply that you can talk to.
Yeah.
It's just spoofing that. It's just so you can modify that without...
Yeah.
Crystal said earlier that it's a large part of the control. Right now, we're just sitting between fully mechanical and fully home system, right? So I'm wondering if, our unbound unit back there actually works in where we do have a thermostat, and it actually connects right to the Loki board, right? And through that way, we actually are able to modulate our miner ramp up and down based off what temperature we're measuring. I'm wondering where, in your opinion, that patch kind of fits in that mechanical to home assistant. Is that something you guys?
Is that spoofing power supply temperature then, or how are you guys getting that into the firmware?
I believe we are taking. It is spoofing the power supply, and the power supply then decides to shut down.
Okay.
It's like a pretty hard shutdown, but it's.
I mean, in the perfect world, we wouldn't need a Loki board from the beginning.
Right.
Like, that's my goal.
Yeah.
Yes, correct. Yeah.
But until that happens, you know.
Well, let's give it 6 months, and we're probably going to have it.
Well,
Yeah,
here's
you
the other
guys
thing
talk
too.
about
Like,
this. I'm gonna.
go
Oh,
ahead.
no, go ahead, Brett.
I was just gonna say I'm not sure if we can actually. I don't know of any firmware that actually provides power supply temperature. I haven't looked into it much. It might be worth looking into. The closest thing, like I said, is Wattsminer provides environment temperature. I don't know where that is, but yeah.
All right.
Okay.
Dwight, I want you guys to talk about this, and I think it's important. But I'm gonna close this out. We'll take those questions you guys can talk about in the other room. But yeah, let's give these guys a round of applause. These guys are doing some heavy lifting.